Welcome everybody to Cloud Native Utah. Really appreciate you coming out. I know I say this every time for the regulars, I'm sorry, but I know it takes a lot of time out of your family lives and work lives and whatever else, hobbies, to come to these meetups. So really appreciate it, come and support. Also, a special thanks to Travis, who's presenting. It takes a lot of time to make a presentation and then be willing to just come share it for nothing but glory.
And that sweet, sweet pin.
And that sweet, sweet pin, which I don't, that's only for the Go one. So we'll make pins for all the other meetups. We may just end up making a Forge Utah presenter pin. An FU pin.
There we go, Clint!
I want one of those.
I want one so bad.
You missed it.
I need to present.
There's a great chat in our Slack channel about why Forge Utah is the FU organization.
Yeah, when you spin up in Slack, it hasn't loaded the logo yet for Forge Utah as FU and everything. I was like, oh, I like that. So, some other announcements. If you saw in the Kubernetes channel, if you're a member of the Utah Kubernetes Slack, we are combining Cloud Native Utah with Utah Kubernetes Meetup. So Paul, right here, organized the Utah Kubernetes Meetup 3 years ago, and has been running it, and he gets outstanding speakers. So we're really excited to bring that into the kind of the Forge Utah umbrella and combine it with this one. We think we're going to keep it named Kubernetes Utah because it's a more recognizable name, but we'll get back to you on that one. So we'll combine pretty much everything: meetups, Slack, whatever.
Location.
Oh, and location. So it's going to be moving here. No more NSA security to get up to Almaty.
Are they still going to be two separate meetups? Or
No, I think we're going to keep making it one meetup.
Which Tuesday?
The Kubernetes Tuesday.
Yeah. The Kubernetes has been around longer, has a deeper following, so most everything's going to just shift to that. So, and it is happening this month still, though. This is the last month it's going to happen, but it will be here.
That's correct.
Thank Mariah for the stickers. She takes care of ordering all the stickers for us. That's in her job description. Sticker queen. What else can I announce? Oh, as you see here, definitely join Slack and Twitter. We have heated debates on whether you should use basil. Today's debate.
Great spice. Use it in all your Italian food.
Yes, it's true.
Or were you talking about basil, Bill?
I think that's it. I'll turn the timer over to you, Travis. I don't have a long, detailed introduction for you. I should.
Sweet.
I will tell this story, which is kind of funny. This is Travis's name placard from, I'm going to call it Motorola, but what was the original company name?
Solution.
Before it got acquired. Public Engines, that's right. Got acquired by Motorola. Our VP of engineering here, was he VP of engineering there? He was VP of engineering there when they got acquired by Motorola. And one of the DevOps engineers that worked with Travis stole his name placard. I don't know why. And then when we found out he was coming today, he's like, "Oh, I've got his name placard." And we're like, "That's odd."
It's been of our coffee, the Keurig pot for probably at least a
just sat
year.
there on the counter. No one knows why.
Watch that guy.
Here it is. You know you can't have it back. It's now Weave property. So,
I expected to go back on the coffee machine.
yeah, that's exactly where it's going. So,
So you know the coffee machine's name.
yeah, that's right. Let's give a round of applause for Travis. Thank you.
Thank you, everyone. So, I guess I have to read here. 27. So I figure most of you read the description of what this presentation is going to be. Hopefully, if not, maybe it'll be a surprise. Either way. So, a little introduction for myself. My name's Travis. It's the awesome placard. I work at NAB. We actually are based out of Draper, and we work with small businesses to help them find financing. So either through like credit cards or loans, wherever else. But we basically try to become a hub for them to associate them with financing that works for them. And so I'm the head of engineering there. We have about 50 people in engineering, split between me and another senior director. So I'm leading the team there. But I have some information here on all of the social networks that matter: Twitter, Keybase, and LinkedIn. So I have, if you want to find me, STMPY. Long, a really short story, literally, hence the name Stumpy, but I get made fun of because my legs are so short. So when I stand up, I'm not very tall, but when you sit next to me, I'm usually sit with the big boys. But that's where, so my friends used to make fun of me, and they said I had stumpy legs, so that's where the name came from. Okay, so we're going to be talking about, this probably doesn't work off the bat, does it? Maybe not.
Work off what, sorry? It will, yeah, it should. It just registers as a keyboard.
To be a, is it this guy?
Yep.
Plug this guy?
These sunglasses were in the kitchen.
Yeah, if you don't have a phone. I'm worried that's going to use screen.
Sorry.
I'll plug that in. Should work.
Oh, you have to add the mouse.
Just not do that.
Sunglasses.
Walk
I
around.
didn't even know we had a clicker.
Hey, you have a clicker.
Thanks.
All right, so we're going to be talking about securing container delivery. And I'm emphasizing this with open source tools. So there's a lot of ways to be able to do this. And securing container delivery, I want to kind of talk about that first. So what exactly does it mean to secure container delivery? Right, so you want to get to the point where you're taking your code and you're getting it into a production system. Right, so this production system is a 1980s mainframe that I found a picture of and figured it was very adequate for our day and time. And the code very well too, right? Like this is the kind of code we want to push to everyone. We want them to stop being sad and we want them to be happy, right? So, but how do you get code from your laptop into a production system in a secure way? There's a lot of things that go into the process. Your code can touch a lot of different places, can be intercepted by a lot of different people. Like even just at your own company, you usually have a lot of developers working on the same code. And so how do you get that to be as secure as possible and get it into your production system? So now being a financial technology company, this is something that is very much at the forefront of what we have to do, because we have to secure a lot of what our customers' information that they give to us. In order to do like credit checks and stuff like that. Like we have all sorts of PII, and we also have information from the credit bureaus that they deem worthy of extreme security as well. So we have to protect that too. So with getting code into production in a secure way is something that we all have to pay attention to. Now, the difference here is like we could probably say we've been doing this all for a very, very long time, right? Well, how many of us have been doing this on Kubernetes or in a cloud native fashion or doing this with containers? How many people have had to do a PCI DSS audit with containers? Pseudo. Sort of. A couple people over here. It's a very different experience. Or like doing it with just a virtual machine or hardware to containers.
Application, the auditors.
Yeah, most auditors have no clue.
Most auditors have no clue, right? Yeah. So maybe to cut this short, what we did is we actually just fired our auditor and we found one that understood cloud native. So we literally, when we went through and we're talking to our auditor, so the first one that we said, what is Kubernetes? And the first one that answered back and knew what it meant, and we're like, hey, you're hired. So that's only part of it, right? But on the other side of it, like there are still things you have to do on your end in order to secure your applications and getting them into your production environment. And on top of that, your production environment in and of itself. So what we're going to talk about are two different things. One of them is content trust. Like a lot of us have a name badge, right, that gets us in and out of our offices. And this is kind of like our ID as to access into a physical location, right? But content trust is more of a digital signature of that same thing, right? Something that is able to be specific to you, specific enough to be able to go to one person, but at the same time, you can also use it in order to verify like where your content is coming from, right? So then the other side of this is content security. So not only do we want to know who our code is coming from, we also want to make sure that it is as clean as possible. So this is an OR room. I don't know how many of you worry about how clean your OR room is before you go in for a surgery. But having been in a surgery before, like you worry a lot about every little tiny detail. And very much so, we should apply that same concept to our code too. We want to make sure that it's clean. We want to make sure that we have kind of dotted all the I's and crossed all the T's and made sure that there isn't anything in our code that could compromise it. So the two sides of this is trust and security. Right? So we want to be able to build in trust through the entire process. We also want to build security checks in through the entire process. So to start, so why trust and security? Why do you think that these two things are important? Why these two specifically? Anyone have any?
Why are both important?
Why both are important? Yeah.
One is that you want to make sure that your, like container trust, is that things have not been changed, that things are, they're the bits that you thought.
Yeah.
And the other one is, do I trust the bits that are in there?
Yeah. So you want to trust who put the bits in there, and you want to trust the bits in there, right? So another reason, and this is kind of one of my favorite reasons, has anyone ever tried to run virus protection inside of Docker? No? All right, so I did a talk at KubeCon last year around doing PCI compliance inside of containers, or with containers. And we were talking about virus protection because that is one thing that auditors are going to look at, is how are you making sure you're removing viruses from your environment or from your software. So I went and found a leading vendor that offers virus protection, and this is what they had as, here's how you use our solution with Docker. Right? So if you start reading this, it's just, some people are already chuckling, so they're probably already reading this, right? So actually, I'm going to skip down to the second paragraph. It says, one way to read, well, maybe not. So when antivirus software scans files used by Docker, these files may be locked in a way that causes Docker commands to hang. What happens when Docker hangs in your production environment? Like your environment hangs, right? Hopefully you have some checks against that, but at the same time, you're probably going to end up with problems. So one way to reduce these problems is to add the Docker data library to the antivirus's exclusion list. So anyone familiar with Docker, hopefully all of us, where is Docker storing all of its information? In the data directory, right? So you're basically saying, ignore everything Docker is doing and scan the host. Right? So you're not even scanning Docker. So you continue on. It says, however, this comes with the trade-off that viruses or malware in Docker images, writable layers of containers or volumes are not detected. Well, kind of like no shit, Sherlock. Like you're not even scanning it, right? So if you choose to exclude Docker's data directory from background virus scanning, you may want to schedule a recurring task that stops Docker, scans the data directory, and restarts Docker. So not only is it bad to have Docker hang in production, but what about like just shutting it off completely, scanning the host, and booting it back up? How many of us have run antivirus scans in the middle of the night and have had like our alerting service go off saying, hey, your service is offline for an hour or so, right? Like this isn't something that's feasible inside of the cloud native environment. So reading this, I just thought, you gotta be joking. Like this cannot seriously be the way to handle antivirus within Docker. So I went to Docker and I found, anyways, I'm frustrated is all get out of it. So I went to Docker and I started reading what they said. When antivirus software scans files used by Docker, these files may be locked in a way that causes Docker commands to hang. This is sounding familiar. One way to reduce these problems is to add the Docker data directory to the antivirus's exclusion list.
They copied and pasted it.
They copied and pasted it. So they went to Docker and probably it took exactly what they said and pasted it on their own website. So Docker's own solution around antivirus software is that it doesn't work with Docker, right? It just straight up doesn't work. So this is a scenario where it's just like, I'm done. There's absolutely nothing you can do in this scenario. Antivirus does not work with Docker. End of the story, right?
VMs, is that what it was?
What's that?
Back to VMs?
Back to VMs, yeah. That's the reason we're all here in a cloud native meetup, right? That's the message. No, so this is where you're using the wrong tool for the wrong purpose, right? So you can have security checks in place, but if they're not doing what they're supposed to be doing, then it absolutely doesn't do you any good. And so antivirus software, or antivirus scanning, as we knew it, isn't adequate in cloud-native environment anymore.
You still pass the audit.
You can check the box.
You check the box.
You can check the box, but does that actually make you safe, right? And when the time comes that you end up getting compromised and they come back and say, hey, you had this virus inside of your system, why don't you antivirus? Find it, you're just like, I don't know, I followed Docker's direction, then I just excluded the data directory. But don't think that'll hold. So anyway, the tool in this situation is not adequate for the job. So what we're going to talk about with this is the 4 C's of cloud native security. But this is where we start to get to a point where we can understand, well, if we can't use these things like virus scanning, if cloud native is enough of a shift for us, how do we start to secure our systems if the systems that used to work no longer work anymore? So you have to start breaking it down, and you have to start understanding, like, what is that solution trying to do for me? Like, what is virus scanning software trying to do for us?
Check viruses.
Find viruses, yeah.
Trying to find the strings that can correlate to those viruses.
Yeah, right? So really what we want is we don't want malicious code running inside of our production environment, right? So can we find another way to prevent malicious code from entering our environment without having to run a virus scanning software? So one thing that cloud native is absolutely famous for is immutable infrastructures, right? Like, instead of trying to nurture your server back to health, you just shoot it in the head and spin up a new server, right? Same thing with our containers. Same thing with a lot of the infrastructure. It's immutable. The idea there is that it's constantly the same as long as you spin up a new version of itself. So we don't want to try to heal it. We want to try to prevent what that image is, or we want to try to know what that image is. And so whatever that immutable piece that we're building, as long as we trust who put content in there, and as long as we know that the content in there has been scanned and is secure, then we have an immutable piece of infrastructure that we know is rid of viruses, is rid of that malicious code, and free of bad actors, right? So when something happens to our environment, all you have to do is use the power of an immutable infrastructure, kill that container or that host, to spin up a new version of it that we know and trust to be good, right? So that's mostly why we come back to why trust the security checks, right? Because we are using the power of an immutable infrastructure. You have to use that to your advantage. Like, this is such a paradigm shift that you don't want to nurture the system back to health. Like a virus scanner, you have a good system that goes south and you want to bring it back up to health. We don't care about that. We just want to have a good system that's constantly running. And if it goes bad, remove it and replace it, right? So that's why trust and security checks. Okay, so the 4 C's. First one being code, second containers, third clusters, and then the fourth one, they call it cloud, colo, corporate, data center. I think they tried to use as many C's as possible for the fourth one to include as many things, but it's basically like your compute layer, right? So first check we're going to talk about is the code in and of itself. So how long is this supposed to go? I don't even know when it started. My watch isn't working.
It usually goes an hour.
It's supposed to go an hour?
Yeah, we started around 6:40, 6:45.
Yeah, I cut people off at 7:45.
Or we'll just, if people need to go, then that's fine, but you can keep going as long as you want.
7:45, so I have like 45 minutes?
Ish.
All right, I'm gonna
It
start
can
a
be
stopwatch,
approximated.
just to make sure I don't like stay too, oh no. Okay. I'm gonna leave that there. Okay, so the first check is the code. So the two things we want to do here is we want to, again, check the trust and the security. So the first one, GPG code signing. How many people here use GPG code signing when they submit commits through Git? Anyone? Anyone know what GPG code signing is? Few people? Okay. What does GPG code signing do?
It proves that you are the author of the code that you're
It
committing.
proves you're the author of the code. Exactly, right?
It proves the identity that the GPG encoding is. It doesn't-
Right, yeah, okay, yeah, but.
Both identity and integrity. So just-
Right. So I'm gonna jump over. I think I had it open. I might not have had it open. All right, here we go. Signing commits. Okay, so basically, to do a GPG setup, there's a lot of different ways to be able to get a GPG key. I have a lab up on GitLab that walks through a lot of this, which is what page I was on. I can link out to this later if we want, but so the other thing is this presentation is off of a lab that I did in for another conference, which was a lot more in depth. We walked through a lot of this, but given we only have an hour and that was 4, and it shortened it significantly. So setting up a GPG key, there's a lot of different ways to do it. I had my thing up there, my ID for Keybase. Keybase is a really good way to be able to do GPG keys as well. But basically the idea, you get a hold of a GPG key, and a GPG key is similar to a lot of encryption keys where you have a private and you have a public key, and obviously that private one you want to keep secure. You ever hear about all those people that had millions of dollars in Bitcoin and they lost it? That's because they lost their private GPG key, right? So do whatever you need to do to keep that thing secure. A lot of times people will put it in a USB and then they'll go put it in a bank vault somewhere. Maybe not that secure, but that works. So, but the idea there is once you have your GPG key, then you can use that to within Git, and Git has built-in abilities. So you can configure it 2 different ways. Like you can configure it from a global standpoint, or you can configure it from a project itself. And it just depends on how often you want to be signing your code. But basically, you'll use your GPG key to sign your commits, and then you can push them up into your repository. So, and what happens there is you can see here with mine that using a GPG key, is verified, or GitLab has verified that this GPG key is technically belonging to me, and I'm the one that has committed the last change. Yeah.
So GitLab has the public key.
Yes.
You've encrypted it using private key that's in your vault.
Yeah.
But how did you do that if it's not on your machine?
The code.
He was just joking about the bank vault.
The private key is on your box. I'm trying to say that it's always how you secure that private key has always been the problem.
Well, so you want a backup copy. Sorry, I should have differentiated. Like you have it on your laptop.
That's assuming your laptop is secure. That's what you're saying.
Hopefully, yeah. You're hoping, yeah. So if your laptop is insecure, then you do want to technically get rid of it as fast as possible. But yeah, like if you lose access to your, encrypt your laptop's hard drive.
Because there are some systems that'll actually just do it in memory. Well, they'll keep it like in a HMS or whatever, and they'll decrypt it just in memory, the private key, and then do the encryption and then throw it away.
Yeah. So like, and there's a few ways to go about it. I think that it really just depends on how secure you want to be around like that private key. Like you could also use just the hardware ones as well and plug them up and use that to sign and then send them off. So there's a lot of different ways to be able to do that. I keep one on my machine, but because
the private key, you're saying?
Yeah, because for me, like part of it is like if you're working on like NSA top secret kind of stuff, you may not want to keep it on your machine, right? Because that could be pretty bad. But for me, in this situation, it's more of an ease of use where I feel secure enough with it on my machine due to like an encrypted hard drive and stuff like that I'm okay with it. But it's really just comes down to how easy do you want it to be or how secure do you need it to be, because sometimes you do have to give and take with those. Yeah.
In your case, you're basically making sure that it wasn't tampered with from when you transfer from your computer to wherever it got.
Yes.
Right?
Yep. So that's what's happening
Like
here.
man in the middle attacked you, altered your code, and
Right.
passed it on.
Yeah. So if you lose access to your computer, someone else gains access to your computer and commits code for you.
Yeah.
That's when you want to go to GitLab and be like, oh crap, delete that key as fast as possible because it's not me anymore, right? And so you can do that, and then you can hopefully do it quick enough to prevent them from sending code up, right? But that is what it gives you. It gives you the ability to prevent an enable from your laptop to where you're sending it. Like in this case, for me, it was GitLab or wherever your code repository is. So then the other thing you can do is within GitLab, now sorry, I use GitHub, but not nearly as much as I use GitLab. So I know the rules in GitLab, but you can do things such as rejecting unsigned commits. So if you do that and you lose access to your key per se and you remove it from your account, then it actually will prevent anyone that did gain access to your laptop from committing into your code repository. Or preventing anyone else that's just trying to forge an identity and push it up. So,
Well, I mean, because there are cases where, just to bring it up, like there are cases like GitHub Enterprise and some other places where admins of the Git infrastructure can impersonate users or have some other outside access. And you say like, well, maybe I'm not worried about some third party, but maybe you're protecting yourself from internal spoofing and over access at other layers.
but even in that situation, like, so if I logged into like our nav GitLab account, and I went in and impersonated a person, like I could act like them through the UI, but I can't act like them.
That's what I'm saying. That's what you're saving yourself from, like, maybe I'm not worried that some weirdo is going to steal my laptop and like, maybe that's not, it should be a worry. We should all be concerned about that. But like there are other ways to get code besides the front end doors and this locks those down.
Yeah.
Some internal person going rogue.
Yeah, exactly. That's what you're just saying. Like you have admin access. You can go be anybody and commit code if they don't have signing.
Yeah, basically, right?
You can go right through the GUI.
Yeah, because you could go in, impersonate them, add your SSH key. Bob's your uncle.
Yep.
But with the GPG key, the thing about that is, like it does prevent you from being able to do that.
Well, SSH keys, if you're not careful with them, are pretty easy for people to get, specifically with like agent forwarding and some other things. Like it, a lot of that's internal stuff. But.
Yeah, for sure. So any other questions around signing commits? Okay, so this is the trust side. So let's go back to, and obviously like there are other things to, like I probably should have put those down here for security. You can do other things to help you feel more safe about what is in your code, right? So the one that I did want to talk about though is Sassed, or static application security testing. Does anyone know what Sassed is or what it does?
Just like a Sonar Cube type thing, or
Say that again.
like Sonar Cube type thing, or
I don't know what that is.
Yeah.
Yes, we are getting confirmed that yes. And I'm not sure what Sonar Cube is. But
Enterprise garbage, right, Paul?
detecting patterns in the code.
check boxes, right?
Yeah. So the one, so the one that I'm familiar with, and given like the static application security testing is specific to the language. So it doesn't always work because what it's doing is it's a static test, right? So it's testing your code cold, meaning that your code's not running on a server. It's actually just looking at the code itself and how it's written. But you get things, a lot of times with whichever one you end up using, you'll get a lot of these checks built into it. So it's like cross-site scripting, authentication checks, format validation, file access, SQL injections, things like that it tries to check within your code itself. So, but you have to remember that this is running cold. So there's only so much it's actually going to be able to do for you. But it is a good check to be able to run really quickly and early within your pipeline. So as soon as you commit code, the few things you could do is you could have that GPG key to verify, hey, this is me committing the code. And this is a very quick check that can run in parallel with a lot of your other tests because it's not intrusive, right? So it's not actually going to do anything or stop you from continuing on your build pipeline. But it does give you a lot of good insight into your code as to whether or not you have some vulnerabilities. So an example here, and down to this one. So an example here, so I ran this against a Ruby application, and in this instance, like it caught an issue with sprockets. basically just said like I have a traversal vulnerability. It gives me the CVE and tells me like what to do as well. Upgrade to Sprockets 372. So as soon as I did that, then you run it and you're like, gives you the good to go, right? And a lot of times within a build pipeline, as long as you return not a zero, you can fail parts of your build pipeline. So a lot of these Sassed tools will do the same thing. They'll return a non-zero when you have a specific threshold that you're passing. That will then prevent that step from passing. So you can make it blocking if you want to, but at the same time, like it gives you that good insight of being able to, again, have content that is secure. So next
Question.
yeah.
Where in the pipeline do you guys run
Run the Sassed.
yeah?
So usually right up front. So a lot of times you have like your unit test, your linting, and like co-climate and all that other stuff running in parallel. A lot of times I'll add Sassed right there along with it. Because it is just analyzing the cold code. Say that one 5 times fast. But it's doing the same kind of analysis. Well, it's doing the same kind of analyzation, but in a different way of what your tests are doing and linting and all of that other stuff. So a lot of times we'll just run it right in parallel as like one of the first steps.
We do it after our build. So we actually do a build of the source, make sure things are good, do a vet there, like a go vet or whatever, and then run it through like a sonar cube.
Yeah, the thing is that a lot of times, like a lot of the next checks become a lot more cost intensive. Because the next one is containers, right? So in order to check a container, you have to build a container. And that takes a little bit more time than just running it against cold code. It's really slow, apparently. All right, so the next C being containers. So the trust side of it, again, we want to trust the content inside of it. So this one, whoa. I meant to double click on that, that didn't work. So patch management. Patch management within an immutable infrastructure, you don't necessarily go into your Docker containers and run updates on them, right?
Shouldn't.
You could.
You're doing it wrong.
You could, but it doesn't necessarily make a whole lot of sense, right? Because if that container dies, you have to go run the update again. So with an immutable infrastructure, you want to build patch management into the build system, into the build pipeline. So an example here, what we do in Nav is that we have an Alpine Linux that we call our Gold Master. And this is the image that we use that we built and we scanned. And so we have a certain measure of trust on that Gold Master image. And an example of this is literally just this file. So Alpine 3.8. We added a couple of tools that we really like. We added some certificates into it. We have a specific entry point that we always use in order to, we use HashiCorp Vault, and that helps us with that. So this is our Gold Master image. So when we want to push patch management or we want to patch CVEs within our OS, this is how we do it. So we update this image and then we push this up so that when developers start building their code, they build it against the Gold Master image, and then they pull those patches down into their build. Yeah.
This is a really stupid aside. Were you guys hit by that big Alpine vulnerability that came out?
I think everyone was, weren't
Yeah,
they?
okay, like I don't know, just.
Yeah, we're in a big push right now to get up to 310. We're having a problem with that because, hey, guess what? I just realized I have a ping pong ball in my pocket. So we're trying to get to 310, but there ends up being a problem with gRPC and Ruby in Alpine 310 that we're trying to work around right now. But yeah, I think everyone got hit by that.
That's scary.
So, but basically at this point, and what we did, this side does take a little bit more maintenance because obviously, like I can't just go up to Docker Hub and go pull like the latest Go image or Python or Ruby or whatever else. But what we did do is within those projects, we just linked to their Docker image that they maintain, and we copied it and pasted it into our own so that we continue to have that measure of trust because we're still building off of our own Alpine image. Then we build basically what they were doing and then push that image. So there are times we have to go back and check what they have changed in order to update our own images. Now, if you have the ability to, a lot of times you can mirror a remote repository, and then you could obviously do some magic in there to pull out that from to put in your own instead of what they're doing, so that you can automate the process a little bit better. So this middle layer with the languages is a little bit more complex, but at the same time, it does give us that measure of trust that we're looking for. So any questions about patch management? So patch management also like vulnerability or virus protection. Like it's not something that you do inside the cluster itself when the stuff is running. It's something that you build into at the beginning, so that when you get to the point where you have an image that you want to deploy into your infrastructure, you already know that you have the latest and greatest software running. So
Quick question.
Yeah.
This, for a base image, this seems like it's not as secure as I'd want it to be as well. And the reason why is, why would I want to have bash? Because I don't want people to exec into it anyways.
Right. So there it is again, like you can kind of take it to the measure you want. For us, well, actually, we're going to get there in just a minute, but you can do vulnerability scanning on the image itself to see like where CVEs are. But sometimes, what's that?
Like JQ has.
Yeah, like JQ has. And I think it's a constant battle, right? But if you want to make it more secure, then there's obviously ways for you to be able to go pull a specific version of the different pieces of software. Now, in this one, like with Bash, Shadow, and JQ, or even curl, right? Like there's probably not things in there that you necessarily need. So again, it's just a question of, where is your comfort level? And
Well, by not having those tools, you sometimes paint your developers into a corner where they can't debug the way they need to debug, or you can't debug the way you need to debug, right?
right.
It's like,
So it depends.
there's no right answer there, I think that's there.
So for us, like it's, with a lot of these things and implementing security systems, we just try to start very simple, and then we build in more layers of security, right, as we get more comfortable with the way that things work. So within this one, this one was a 3.8, and I think the 3.10 just got released. So this one's not even really all that up to date. I don't even remember when I took this picture. But at the same time, it is really just a question of how much security do you want as opposed to ease of use in this situation. So the next part to this, though, is actually, let's get down here to the vulnerability scanning. So to do that, we're actually going to skip over to Project Harbor. How many people have heard of Project Harbor? A few hands. Okay, so Project Harbor is a container registry built on top of Docker's version 2 registry. And I've got an instance running right here. So the other two pieces that I want to talk about are actually covered inside of Project Harbor. So Harbor does a vulnerability scan here. So I have that the same Rails API that I use to run the security check against, or the Sassed check. And so then I've uploaded it to Harbor, and Harbor has gone and used CoreOS as Claire. I guess they're not CoreOS anymore. Red Hat's, I'm still going to call them CoreOS for being safe. But it's using Claire in the background, and Claire is a vulnerability check management system. I don't know how best to say that. Scanner. So within this image in and of itself, oh crap, I logged out. Let me log back in.
What does it cost?
Harbor's free. This is all free. Open source.
Yeah, Project Harbor is free. So
Sorry, Claire, Harbor. VMware, isn't it coming out of?
So if you go to goharbor.io, you land on Project Harbor's page. Harbor is actually part of the CNCF now, so this is an open source project. I wish that, I keep trying to find an image of their their infrastructure or how they built Harbor, but I've only ever seen it in like their presentations. So
It's not very hard to get up.
no, it's really easy to get running, yeah.
Yeah.
But at the same time, like all of the different pieces integrated with it, because a lot of people ask like, why not just use Docker registry? It's like, well, actually this is Docker registry with a lot of other things on top of it, right? So one of them that you get is Claire, which does, let me jump back in here. So which gives you the vulnerability scans, and you can rank them here to see like what your problems are, right? So where the CVEs are. So our security guy at NAV, his favorite saying is the biggest vulnerability is time. So just give it enough time, and everything probably at some point becomes vulnerable. So this image that I've been building against is a pretty old app that I wrote a long time ago. So given an amount of time, like I've got 24 high vulnerabilities just because I haven't updated it in a fair amount recently. So the nice thing here though is that it gives you the severity, it gives you the CVE, so you can link off and go see like what the vulnerability is in and of itself. But it also gives you like what to do. So a lot of these things, the fix is literally just upgrade it, right? So hopefully you're still using software that's maintained by wherever it came from. Most of the time they're going to release a fix for their CVEs pretty quickly. So usually all you have to do is just go in and upgrade your software, and you'll get rid of most of your CVEs until you wait for a little while longer until someone finds some more vulnerabilities. Then you go do the same thing. So, any questions about this or Claire? So, maybe
Travis?
that one.
Travis?
Here.
Yes.
Will Harbor alert you if vulnerabilities come up?
There's some hooks.
That is actually a really good question.
I think there are some hooks that you can put in to call out. I think.
Yeah, I don't think that it has it built in yet. Harbor's been around for, I want to say like, it's been around for a while. I would say like 3, 4, 5 years maybe. No.
About 3.
Maybe 3 or 4. 5 is like Docker age, but they've really started picking up a lot of steam within the past year. So like I was looking at them about a year ago, and it's like, oh, that's cool, but it doesn't really like give me enough to want to use it yet. But within the past year, they've done quite a bit to upgrade it and get it to a more usable state. So they're still like very, very actively working on it. And you can actually go to their GitHub.
But it's still incubating, isn't it? It's not a graduated project
It's
yet.
still incubating.
Which doesn't mean anything, but.
But the awesome thing though is that it's like the only registry that is incubating. So they don't actually have any other registry incubating systems. So as far as the CNCF getting it attention, it's actually been really, really good for it. They became part of the CNCF about a year ago, and that kind of randomly correlates to the fact that it's picked up a lot of steam over the past year, right? So a lot of people are interested in having technology like this, and so it actually has become a lot more maintained and updated. So they have an active, they actually just released another webcast not a month ago. They were talking about the next roadmap and what they're doing. So I do believe they're like calling out, being able to send alerts and notifications as part of it. So the other thing is that another piece with Harbor that again they do in their presentations or their webcasts, but I don't have a good example here, is Harbor has a way to be able to create, let me see if I can jump into this. You can link multiple registries together. Oh yeah, there we go. Duh, it's called registries. So you can add endpoints, and you can add another Harbor one, or you can add Docker Hub, Docker Registry, or right now only Huawei SWR, but they're adding support for AWS's registry and GCP's registry as well. So what this means is the advantage you get here is that you, with, so how many people using registries have more than one registry between like what their build system is using and what they're pushing into production? So a couple people. So like the one that you're building against or the ones that your developer is using usually get really polluted and have all sorts of crap in them, right? But you don't necessarily want that inside of a production registry. Hence the same reason you don't necessarily want to pull straight from Docker Hub into your production registry, because you have no idea what's in there. So the awesome thing here is that Harbor had, and this is already functional, they already have this ability in there. So you can link multiple Harbors together, or you can use just a regular Docker Hub or Docker registry to be able to graduate images from one registry to the next. So you can have a registry that's like your build system, and you can have another registry that you use to only pull out of for your staging environment. You can have another one that you only pull out of for your production environment. So you can take an image and you can graduate it between the different harbors in order, as your trust increases in it. So while you don't necessarily get notifications that there's vulnerabilities inside of it, like you can go and look at it and say, well, I don't necessarily trust that image, like I'm not going to graduate it, right? So, the great thing there though is that you can get to a point, even within your registries using Harbor, to get to a point where you know that within the production system, you're at a percentage of content trust and security. You know that it's been scanned, you know that vulnerabilities have been removed, and by the point it's getting to the registry, hopefully, it's also been signed from the code, and we'll talk about the signing of getting it to the registry in and of itself. So you again can build in another layer of trust. So, any questions about that? Yeah.
So can you put like the vulnerability scan in the pipeline and have it break if there's a vulnerability?
You can. So Claire, I had it up here.
Can you do that with just Harbor or?
So you definitely can. You can make it break. Oh gosh, dang it, wrong button. So there's a few different ways to do this. Like you could definitely do it that way, to where you just add the vulnerability scan inside of your build system to have it stop at that point. But if you want if you want Harbor to do it, you could have a different call out, right? That once Harbor scans the images, then it sends like a webhook in to fire off another part of your pipeline. So you can do it both ways. The other side is that you have to manage your own Claire or whatever your vulnerability scanner is. There are a lot of them besides Claire. You can literally just go and look for open source container scanner, and you can find a lot of them. So a lot of them are actually open source as well. So Claire's not the only one, but Claire's just the one that Harbor uses.
There are actually several projects, but one, if you're interested in the pipeline, there's actual a command line to Claire that you can actually put in to scan first before you do the publish.
Yeah.
So
there's a Claire, I think it links to it, CLI. Client. Oh, man.
I think it's a different, yeah.
Lab even has their own. Yeah.
There's several out there.
There's
Hyperclaire and yeah.
probably.
I think it was, I looked at.
Command line tools, scans.
KLAR now.
Yeah.
I think it was.
CLI. There's a couple of them. So, but yes, like there's a way to do this kind of inside the pipeline instead of like having Harbor do it itself.
There's quite a bit. So I saw something else in there in Harbor to do with image signing. So you get into that.
Yes. So, anyone heard of Tough?
Team.
All right.
The update framework.
So Tough is the update framework. I think I'm on mode already. But basically, the update framework, long, complicated. They built Notary that is an implementation of the update framework. And what Notary does is basically like for code signing where you have GPG keys to be able to sign your code to send it up into your registry, you can use Notary to do the same thing for for images. And actually, it's not even specifically images. You can use Notary for a lot of other things. But it's also really nice for images. So what you do is, and this is another piece that Harbor gives you that I don't actually have it running inside of my project right now. You can see right here that this signed just had this strike through because I don't have, I'm not signing my images yet. But when you use the Notary CLI, or a lot of times, like what you're going to end up doing is building it into your pipeline, right? So when you get to the point where you want to push an image to Harbor, to your registry, you use Notary that will then sign your image and then push it to the registry, which gives you that content trust again. So you GPG key from your code to the code repository, and then you can use Notary from the code repository to your image registry in order to continue that content trust. So, and then like the basic layout, this is like the very, very simplified architecture, and then they have this awesome, this is what's actually happening in the background, right? So there's a lot of things happening here, but at the same time, so it's using Tough underneath the covers, and Tough is actually the people that build Notary. They just, Tough is more of like a framework in and of itself. Actually, the F stands for framework. So it in and of itself is just like how you would want to do this, and then Notary is the implementation of it. So then basically you can see that it's just going to go through it. You're using private keys and public keys again in order to do the image signing, but this just gives you the verification and content trust from your code repository to the image registry. So you again add that other layer.
So the goal here is like, I've seen some vulnerabilities where people got their Jenkins hack, they were injecting stuff during CI/CD. This would detect if something changed during CI/CD. Is that the case?
Yes.
Okay.
Yeah,
no,
so, yeah.
no, because you could still, Jenkins could still change the thing, change the code, and still sign it and send it on its way.
So Jenkins would be the one.
This is basically to ensure like every image you run, you can say only run trusted signed images, so that you know that someone's not pulling in some out of bound image from an upstream registry somewhere, and like
Find a way to inject
some of it, yeah.
Just retagging an image that you built locally as an image that you, yeah.
Oh, okay.
Yeah, like if you don't want developers pushing into your registry, like your production registry, you'd want it locked down with image signing for sure. So you can prevent them from pushing to that registry with something like this. Like you could obviously lock it down a lot of other ways, but Notary helps give you that too. Well, on the prevention side, but then you also get the verification on the, like it came from where you're expecting it to come from.
Okay.
So similar to GitLab, like you can enable content trust, and you can do some other stuff within here in order to basically only allow that verified image in order to get pushed up. So you can create that denial of I don't want just anyone pushing to my registry. I only want something that is signed that I know and trust. So I'm going to be I probably should have said this up front, I'm not a Notary expert. I usually have another guy that helps me with it because Notary is great, but like from this thing, well, the nice thing is that Harbor has it built in. So it's running the Notary server. So it has the server and the Tough, and it has to sign a database and all this stuff. Like you really just have to do the other side where you set up the Notary keys and then sign your images and push them up. So you kind of get to walk away from that. I have no idea how to run the Notary server, and nor do I want to like worry about it. You don't have to, because Harbor takes care of that side for you too. So that is what you get out of here. And I think that I've got like 10 minutes left. So Harbor, any questions about that? Okay, let's see what else I had in here. We talked about Notary, that stuff. Okay. The third, okay, awesome, is the cluster in and of itself. So if we go back to looking at the 4 C's, so now we're down at like the Kubernetes cluster. So at the Kubernetes cluster, how do you get to a level of trust and security? So there's a couple of things you can do here. Trust, there's this project called, I don't know how to say it right, Portieres is how I'm gonna say it.
Yo-yo?
What? It's as good as my guess. I don't know. But anyway, this came from IBM. This is probably like the only thing in here that isn't, well, actually there's another one, Falco. Yeah, OPA is part of the CNCF, but Portieres isn't. So this came from IBM, but basically what it does is you kind of inject it on the Kubernetes side, and it also is using Notary as well. So you kind of extend that Notary from, not only can you sign from your code repository to your image, nope, that was backwards, code. Anyway, where you store your images in the registry to it getting to the cluster itself, it'll use Notary again to verify that if it's pulling an image into the cluster, that it is signed using Notary. So you get that content trust, but then once it does that verification, I think it had an example up here. Yeah, so once it does that verification, it uses an admission controller inside of Kubernetes. Anyone familiar with admission controllers? You guys use a lot of Kubernetes, don't you?
Yeah.
So I think I had another example from OPA. Yeah, this one's a little bit better. So, oh my gosh, I don't know why I want to keep hitting P. So an admission controller, you can have like a mutating or a validating admission controller, which means that when something comes in to the Kubernetes API, then you have like a hook that wants to run against that request. Now, whatever that hook does, you can mutate the request or you can validate the request in a different way. And so what Portieres does is I think it's only a validating one, to where, no, it is mutating because it changes the image name. So once it comes in, it'll verify it, it'll go check against Notary, make sure it's signed, and then it actually rips out your tag and replaces it with the SHA-256 hash. And so you know for a fact that you're only running that specific image. And then it sends that to Kubernetes as the image name to be running. So at that point, it has verified content trust, and then it's like, I'm not going to play the tag game and hope that you put the right tag on here. I'm going to go grab this SHA that I verified, replace it, and you're only running that image. And so Portieres, sorry, IBM's thing, that's basically what it does. Is it stands in there as a admission controller, checks the request coming in, verifies the images, and then will only run that inside of your container. So the other one here I have open already is called OPA, Open Policy Agent. So what you can do with Open Policy Agent is kind of something very similar. But in a sense, like if you have a registry that's set up only for your production container, or you only want it to be pulling from your production container registry, you can add another admission control using Open Policy Agent that will do some verification to say, where is this image coming from? And if it's coming from anything other than this web address, I don't want to allow it. And so you can deny requests coming into your Kubernetes API server based off of where that request is coming from. So if you want to deny Docker Hub, then you can set up an OPA policy to say deny anything from Docker Hub.
OPA is really cool. It's sort of a general purpose, like best practices enforcer. Rather than saying, this is what we should do in our clusters, you say like, you can't commit a pod that doesn't do X or does do Y.
Yes.
Right? And it enforces that rather than just having a, we should or shouldn't kind of opinion.
Yeah, I think that's a good way to explain it. And it's very much like a Swiss Army knife. Like there's so many things you can do with OPA. You can run it like a sidecar next to your containers to be able to do the same thing from like a service level to reject or allow traffic based off of particular rules. Or as wide as, protecting the entire Kubernetes API, which is something that does need protected. So OPA is another one that's freaking fantastic. They have a playground. I highly recommend going and looking at OPA. It does a lot of things. Then Falco. So Falco is from Sassed. This is like Sassed Secure. If anyone knows, that service is built on top of Falco. But if you watch the little example up here, basically, it is running live. So it is the runtime protection. So we've done everything we can to make sure that once you get to the environment, your production system, that everything is secure. Now, what happens if something changes? We want to know about that change inside of our system and be able to remove that, right? We want to use the immutable infrastructure in this situation. So we want to know when our images or when our clusters or nodes change. And that's what Falco provides to you. So you can see in here that they're executing into a container, and Falco is giving the notices up top, right? So it is showing, hey, like you had a small container, files are changing, all this different stuff. So you can catch those. Those can spit off into any system you want, really, to be able to feed back into Kubernetes and say, hey, I had something weird come from this container, just kill it. And then Kubernetes will kill it and pull it right back up, right? But that's what Falco gives you. So a lot of this other stuff is all in the pipeline, getting it to Kubernetes in and of itself. And then Falco helps make sure that whatever is running in Kubernetes is what you expect it to be. So, and again, like Falco in and of itself is open source, and it is also, it is part of the CNCF, and you know that. But you don't want to deal with running your own Falco. You can use the paid service called Sassed Security, and you also get a lot of other functionality on top of it. But the important part is Falco, and that's where a lot of the functionality is. So that piece in and of itself is open. So then the final, so any questions there? Down to like 3 minutes. Oh yeah, fourth, cloud compute, like your own infrastructure, whatever you're doing, this is extremely variant. So you can do a lot of things, but this is, like if you're running in a cloud provider, a lot of times they give you really good resources to be able to check your own security. So all of them have some sort of security or trust built into them. If you're running your own, like this is where a lot of the I shouldn't say old, a lot of the secure systems that have been built previously will come into play, right? So if you're running your own hardware. But as far as the cloud is concerned, all of the major cloud providers have a way to be able to monitor and measure security and be able to alert you and notify you on a lot of that stuff. So you really just have to kind of go to them and say, what do you recommend to me as my best practices in that situation? Then I think that's it. Did I make it?
Sure.
Good.
Barely.
Spare.
Okay, any questions?
How much of this stuff do you use in production at NAV right now? Use all of it?
How much of this are we using?
Yeah.
So
It checks all four.
we started implementing this a couple years ago, where some of these were still pretty new. So we're not on open source versions, we're on paid proprietary. So we're using Twistlock for like the image scanning, and instead of Falco, Twistlock has a defender that's running inside of our environment to do that check for us. And so a lot of the things that Harbor provides and you get from Falco, and then those other things we get from Twistlock instead. We do like the image signing, but we don't necessarily heavily enforce it, only on particular projects. Once that we classify as red, or that should be highly secure. So I'd say for the most part, most of it, but not necessarily all of it. We're not using Notary yet. So the image registry is the next thing that we wanted to get in and replace. We've been wanting to rebuild our registry system for a long time. So that is one of the next things we're doing. Any other questions? We asked a lot of them throughout the whole thing.